Let's see how you're doing on these. I realize some of you might not be totally finished, but that's okay. So our first one here, we have 513 square feet. And we're converting into square yards. Now the square yard is the bigger unit, so we're going to put the 1 there. But we have to remember this is not 3 feet in a yard because it's not yards and feet. It's square yards and square feet. So while 1 yard is 3 feet, 1 square yard is 3 squared, or 9 square feet. So the square feet cancel out. This is 513 square yards over 9. 513 divided by 9 gives us 57 square yards. For number 2 here, doing the metric, just have to remember we got meters, decimeters, centimeters, and millimeters. Here we are going from millimeters to centimeters, which is only 1 spot to the left on our chart. But it's not millimeters and centimeters, it's millimeters cubed and centimeters cubed, which means every spot on the chart is multiplying or dividing by 1,000. In other words, it's 3 decimal places. So my decimal point, which there isn't one there, so that means it's at the end of the number, has to go 3 spots to the left. So that is 23 centimeters cubed. That's a tough one for a lot of people to catch because they're so used to just moving 1 decimal place for every spot on the chart. But if it's squared or cubed, it changes it. Number 3, 2.5 cubic feet. Put that over 1. We're going to get rid of the cubic feet, so they're going to go on bottom. Cubic inches on top. Now again, we know that 1 foot is 12 inches, but this is not feet and inches. It's cubic feet and cubic inches. So 1 cubic foot is 12 cubed. 1,728 cubic inches. So the cubic feet cancel out. We just have 2.5 times 1,728, which is 4,320 cubic inches. Moving down to the next set. Number 4 is metric again. We're going to go back up here. 0.0038 meters squared into centimeters squared. Well, from meters to centimeters is 3 spots or 2 spots to the right, but this is squared, which means every spot on the chart is 2 decimal places. So 2 spots on the chart becomes 4 decimal places. So we go 1, 2, 3, 4. That is 38 centimeters squared. 6,912 square inches going into square feet. We're going to put square inches on bottom, square feet on top. Now square feet, the foot is the larger unit, so that's the 1, goes with that. 1 foot is 12 inches. 1 square foot is 12 squared, or 144 square inches. So the square inches cancel out. We have 6,912 square feet over 144. We divide that, I believe that's 48. And it is, that's 48 square feet. And finally, we have acres. 1.8 acres. 1 going into square feet. Well, 1 acre goes on bottom, so it cancels out the acres, is 43,560 square feet. Acres cancel out. 1.8 times 43,560, 78,408 square feet. Any questions there? Okay. Well, there is a new quiz out there. Actually, I think one of you's already finished it for today. This is on the length units and areas and volume units, what we just did up there. So make sure you're careful with that. If you've already submitted it and I haven't graded it, feel free to go back and double check it yet. You can still do that. Now today, we're going to talk about volume and capacity. And before we do that, I want to talk a little bit about What is the difference between volume and capacity? Volume is found by combining length units. Or just combining lengths. A volume for a box is length times width times height. 3 length units combined. All volumes are some combination of 3 length units. So the units used are just that. A length unit cubed, like inches cubed, or feet cubed, or meters cubed, or centimeters cubed, or whatever length unit we are using to measure those lengths. If I have a box that is, well, let's go 6 feet by 3 feet by 2 feet. The volume is simply 6 feet times 3 feet times 2 feet. Well, 6 times 3 is 18. Feet times feet is feet squared. 18 feet squared times 2. 18 times 2 is 36. Feet squared times feet is feet cubed. It's 36 feet cubed, or 36 cubic feet. That shows that volume unit is just a length unit to the third power, or cubed. Capacity is actually standard sized containers. Both capacity and volume measure how much something will hold, or how much space is in something. It's just how they go about it. Volume, like I said, comes from those lengths. Capacity comes from these standard sizes. Let's start off with one of the larger units of capacity that we have, and that's a gallon. A gallon was actually the size of what you could hold in a men's hat. Not talking about, the cowboy hats or anything like that, but we're talking about a European style dress derby type hat. That was 1 gallon. The cowboy hats, you hear them called a 10-gallon hat. That was kind of a sarcastic term, because they were bigger hats. People say, oh, you got a 10-gallon hat there. It was just kind of making fun of them a little bit. Smaller than a gallon, we have quarts. Now, the word quart actually comes from, it's a shortening of the word quarter gallon. So that means there's 4 of them in a gallon. One quart, which is abbreviated QT. So the quart obviously is defined as part of a gallon, as a fourth of a gallon. Smaller than a quart, we have pints. Now, pints were a unit on its own. It was a standard sized jar. It was used for preserving fruits and vegetables, or for any produce, and it was also used for serving drinks. You'd order a pint of ale or a pint of whiskey or whatever. So the sizes of the quart, the pint was a standard jar that already existed. They weren't going to destroy them and resize them. So they kept the pint pretty much the same. The quart was adjusted to make 2 pints fit in a quart. So when the quart got adjusted, the gallon got adjusted. The gallon that we use now is actually quite a bit bigger than what the original gallon was, what the original hat would hold. Smaller than a pint. Now, a word of warning here, by the way. Quart is abbreviated QT, and in some fonts it looks like that. Pint is PT. It's really easy to confuse those 2 abbreviations, so be very careful when you're looking at them. Go slow and make sure you don't read too fast and mix those up. Smaller than a pint, we have a cup. Now, a pint was liquid measure. It was measured fluids, whiskey, ale, whatever, drinks. It was also for preserving foods. Usually there was water put in there as a liquid in it, so it was a kind of a mixture of solid and liquid, but the pint was mainly liquid measure. Gallons and quarts could be either liquid or dry measure is the other term for it. A cup originally was strictly dry measurement. A cup was, for bakers, if you're doing flour or sugar, is literally how much you could dump in and heap up on your cupped hand. That's where a cup came from. 2 cups equals a pint. I have a good friend of mine that's a caterer, and I've double checked her a couple times. That's all she does is dumps it in her hand, and she is dead on every time she does it. Oh, smaller than a cup. Yeah, fluid ounces. 1 fluid ounce is actually defined to be the size of 1 ounce of water. 1 cup contains 8 fluid ounces. Smaller than a fluid ounce. 1 fluid ounce contains 2 tablespoons. Smaller than a tablespoon. 1 tablespoon contains 3 teaspoons. Now, another side note here on abbreviations. Tablespoon can be abbreviated with a capital T, SP, or just a capital T, or a small TBSP. I exaggerate it. I always abbreviate it with a capital TBSP, just to be clear. Whereas a teaspoon is abbreviated either with a small t or a small TSP. You can see, small t and capital T, it's real easy to mix those up. And TSP, again, the only difference is a small t or a capital T. Be very careful with those. If the recipe calls for 2 teaspoons of salt and you accidentally put in 2 tablespoons of salt, there is no amount of milk that's making those cookies go down. Trust me. I haven't put a lot of cookies to waste. That batch went in the garbage. Now, you don't have to take any notes past this. These next couple of units I'm just putting out there just to show you that they are real units. Smaller than a teaspoon. A teaspoon contains 8 dashes. Or a dash of spice or whatever. A dash, if you think of a salt shaker, a dash would be tipping it like that and letting what salt comes out. Spice shakers are similar to salt shakers. They're much bigger, but we just give them 1 tip of the spice shaker is a dash of spice. There are 8 dashes in a teaspoon. 1 dash contains 2 pinches. A pinch is exactly what you think. You reach down into the spice or the flour or whatever, and you pinch your fingers together. What's between your fingers goes into the recipe. And if they're smaller, there's another 1 pinch is equal to 2 midgeons. It always grosses me out a little bit. A smidgen is if you stick your finger into the spice, whatever sticks to your finger goes into the recipe. In order to get it to stick, I'm always picturing the cook doing one of those things. It kind of grosses me out a bit. It cooks off, right? There are bigger units, by the way. Bigger than a gallon. Being from northern Wisconsin, we should probably discuss bushel. 1 bushel is 8 gallons. Another one that comes up that you've probably heard but didn't pay a lot of attention to is a peck. You may have heard it in the old nursery rhyme, Peter Piper picked a peck of pickled peppers. But you also want to see if you go to a strawberry patch and buy strawberries, they got trays of strawberries out there. They usually have 1 peck or 2 peck trays. 1 peck is 2 gallons. If you go to an apple orchard and buy apples, same thing. You have 1 peck and 2 peck containers of apples you can buy. So 2 packs would be 4 gallons. But again, a very important measurement in northern Wisconsin is the barrel. A lot of people would say 55 gallons. That is not true. 55 gallons is a drum. So like a oil drum or something like that. The big metal, most people call them big metal barrels, but they're actually large, they're metal drums. They're not truly barrels. Barrels are actually quite a bit smaller. The big plastic ones that they make garbage cans out of, those are also drums. Those are not barrels. A barrel is 31.5 gallons. So a quarter barrel, which is, like I said, a very important measurement in northern Wisconsin, that is 7 7/8 gallons, or 7.875 gallons. Now, there are other measurements like a hogshead and stuff like that that I'm not going to put in there because those are old agricultural measurements that really don't get used anymore. These are the ones like a bushel, you'll hear that all the time. A peck, you'll probably run into it if you buy any sort of fresh produce. Barrels, maybe not so much either, but those are ones that you have a possibility of at least encountering. Now you can see here, there is a cluster of units here in the standard system for capacity. Quarts at least go with gallons, but gallons, pints, cups, fluid ounces, tablespoons, dashes. There's almost a dozen different, well, there's more than a dozen if we include all the ones we didn't name. Different units there that go together and have, each of them has these weird different conversions. And there's no connection, even though they really are measuring pretty much the same thing, there is no connection between volume and capacity. 1 cubic foot, remember 1 foot by 1 foot by 1 foot, does not have a nice, neat conversion into gallons. If you think of a 5-gallon bucket, if you ask yourself, do you think that's bigger than a cubic foot, smaller than a cubic foot, or about the same? Most people would say a 5-gallon bucket is about the same as a cubic foot. Actually considerably smaller. 1 cubic foot, technically 7.48 gallons. I usually go with just 7.5 gallons is 1 cubic foot. So a 5-gallon bucket's only about 2/3 of a cubic foot. Again, not a real neat conversion. Going the other way, 1 gallon, it's not even exact, it's approximate, is approximately 231 cubic inches. So again, really ugly conversions between units that really should be measuring the same thing. So when they went into the metric system, when they created the metric system, that was one of the biggest, two of the big things they wanted to eliminate. One was they wanted to eliminate all those different units, a dozen or more units for capacity. They came up with 1 unit of capacity. That was the liter. That's the only unit of capacity. All other units are, again, tenths, hundredths, thousandths, or multiples of that liter using those prefixes. The second thing they wanted to fix is that lack of connection between capacity and volume. In the metric system, of course, volume would be meters cubed, centimeters cubed, millimeters cubed, and so on. Well, to make a link between them, they defined 1 milliliter to equal 1 centimeter cubed. And actually, that's not how they defined it. It actually just worked out to be that way. What it really ended up to be was 1 liter is one, and this is one of the few places it was ever actually used, 1 decimeter cubed.
Sorry for vanishing.
No problem. It looks like you're having technical difficulties. So anyway, so 1 liter equals 1 cubic decimeter. 10 centimeters by 10 centimeters by 10 centimeters is equal to 1 liter. Now, when I was young, when I first learned the metric system, I was told that you had to always capitalize the L when you abbreviated liters. It was a capital L. I found out later that that's not necessarily a rule. It was just done for convenience, so that if you write something like that, is that 51 or is it 5 liters? Well, if you make your capital L, then it's pretty obvious that that's 5 liters. And even back in that day, I went to middle school in the late 1980s, so it's been a while. Typewriters and stuff, printers, ones and small L's looked very much alike. Now we have different type fonts that they're distinguishable. But before, in order to make sure that we didn't confuse them, they did use the capital L. But that isn't something really built into the metric system. So it is okay to abbreviate with a small L. So our main unit is liters, and I'm just going to use the capital L out of habit. Deciliters, of course, was 1/10 of a liter. Centiliters was 100th of a liter, and milliliters is 1,000th of a liter. They skipped 10,000, 100,000 again and went to microliters is 1,000,000th of a liter. They skipped to nanoliters, was 1,000,000,000th of a liter. Going larger, hectoliters was 10 liters. Hectoliters was 100 liters. Kiloliters was 1,000 liters. A megaliter would be 1,000,000 liters if we kept going. Well, we didn't really ever need anything that large. The kiloliter even, well, like most of our units, many of those secondary units didn't get used. We use the main unit, we use milli, and occasionally kilo. For medical purposes, we use microliter. Nanoliter is too small to really measure for medical purposes outside of medical research. The nanoliter gets used a lot in medical research. But we do have the kiloliter, the liter, the milliliter, and the microliter. If you are in medicine, by the way, if you're working in medicine, that Greek letter mu that's used to abbreviate for micro, they typically, because the medical fields was one of the first fields to have to keyboard everything into the computer, and there is definitely no mu key on the keyboard, what they did was they just changed their abbreviation to MCL. So MC stood for micro. So if you ever see MCL or MCM, that's just the medical abbreviation for microliter or micrometer. Kiloliter is about 280 gallons. So that's a little large. So we definitely don't need the megaliter. 280,000 gallons is pretty big. So the kiloliter doesn't even get used that much. There's one. Oops, go ahead.
Isn't like a kiloliter like about the same size as a pool? Like amount.
Yeah, it would be really. Well, a kiloliter is about 280 gallons, which is only about 40 cubic feet. So it would be a small pool. Like one of your little 8-foot round pools that are 3 feet deep. That would probably be
I was just trying to imagine that in my head to help me.
Let me think. A 10-foot pool would be 78.5. Yeah, a 10-foot pool about 4 feet deep. A 10-foot diameter round pool about 4 feet deep would be about a kiloliter.
Okay, thanks.
You bet. There's one obscure use, not really obscure, but one very specialized use, I should say, for deciliters. All of your medical testing is done in deciliters. If you go have your cholesterol checked and it comes back as 185, well, that is 185 milligrams of cholesterol per deciliter of blood. Or if your blood sugar comes back at a 72, again, that's 72 milligrams of blood glucose per deciliter of blood. But that's really the only application I've ever seen of deciliters in medical testing. Blood and urine testing is about the only place I've ever seen deciliters used. The conversions are exactly the same as for inches or for meters and centimeters and millimeters. If I have 0.27 liters and I want to convert that to milliliters, well, to get from liters to milliliters is 3 spots to the right on the chart. I move my decimal point 3 spots to the right. I have to add a 0. That 0.27 liters is 270 milliliters. Very common conversion in the medical fields. Might get 0.08 milliliters. You want to convert that into microliters. Well, milliliters to microliters, even though there's no names for these spots, they're still there. It's 3 spots to the right on the chart, so we move the decimal 3 spots over, adding a 0. That's 80 microliters. I mentioned that natural connection between volume and capacity in the metric system. If we have a tank that is 60 centimeters by 25 centimeters by 20 centimeters, the volume is simply going to be length 60 centimeters times width of 25 centimeters times the height of 20 centimeters. What's that come out to be? $1,500 times 30,000, I believe, centimeters cubed. Let me double check that. 60 times 25 times 20, and it is 30,000 cubic centimeters. That's the volume. I want to know, let's know how many liters does it hold. Well, we know that because 1 cubic centimeter equals 1 milliliter, that's by definition, that this 30,000 cubic centimeters is equal to 30,000 milliliters, because they're the same. And now we can go from milliliters to liters. Now look at our chart, milliliters to liters is going back 3 spots to the left. I can take my decimal point and move 3 spots to the left. That is 30 liters. Just to give you an idea of how big that is, 1 gallon equals about 3.785 liters. I think your book might actually just use 3.79. It's just a rounded conversion is all. So take 30 liters, put it over 1. We're going to multiply. Liters will be on bottom here, so 1 gallon on top, 3.785 liters on bottom. The liters cancel out. On top, 30 times 1 gallon is 30 gallons. On bottom, 1 times 3.785 is 3.785. And we'll divide that out. 30 divided by 3.785 is 7.93 about gallons. So a little bit less than 8 gallons. With that, that's about all I have for new material. So looking at that packet we're working out of, page 238 of the packet, problems 43 through 50, are dealing with standard units of capacity and volume. Page 265 of the packet, problems 41 through 48, are dealing with metric units of capacity and volume. So I'll let you guys have our last 13 minutes here or so to get started on those. I'll be on the network here to answer any questions if anything should come up.